All right, folks, I am just recording a couple of things for you to help review go a little smoother. And there's really four conics that we're actually going to talk about overall that you're going to be tested on. The first are parabolas that I'm going to kind of briefly review. You have ellipses, circles, and hyperbolas. Now, in terms of parabolas, the one thing that I really want to make sure I hit on with you is that whatever is squared will determine what kind of parabola it is. If it's x squared, it'll be a vertical. If it's y squared, it'll be horizontal. In the equation, the 4 is your constant number. The p itself represents two things. It represents distance and direction of the focus point. So if you're ever given the focus point, that gets plugged in for p. All right, now, the reason why I want to talk about that is in the packet that you got earlier, there's a little bit of confusion on what is the focal point and when do I divide by 4, when do I multiply by 4. Well, the first thing is anytime you're given any sort of equation for a parabola, something like this. I know that this is a parabola because only one of the variables is squared. So the first thing I need to do is get that one variable by itself that's squared. That's done. All right. Now from here, this isn't technically in standard form yet. What I need to do is I need to factor out of 4. Factoring out of 4 means that I'm going to divide this by 4 to see what do I get. Now when I divide it by 4, you get negative 3. This number, excuse me, this represents the p-value. So when I rewrite this in standard form, it'll be y squared equals 4 times the p-value, x. All right, now, what does that tell me? It tells me a few things. It tells me, first of all, that my focus is going to have something to do with negative 3. Easiest way that we just talked about in class is to figure out if negative 3 is the x or the y. Just look at the letter next to it. Since that letter next to it is x, negative 3 is going to go in the x value. Now, the flip side of that is the directrix. The directrix deals with the line that's behind, that's the vertex. It's equidistant from the vertex. Well, since x is also the variable again, it's going to be x equals whatever you got for the p-value. All right. Now, in terms of graphing this thing, since we are talking about it and some people are a little confused with the graphing, what you need to do with the graphing is you need the focal width, which requires you to go back to the equation before you factored out that 4. And the focal width is 12. It's the absolute value because it's really just distance. So let's take a look at what this graph will look like. Let's pull a graph up here real quickly. Okay. Sorry, give me a second here. Here we go. What I know is I know that my vertex is at 0, 0. So I'm going to set that dot there. My focal width is 12, which doesn't really help me very much. My focus is at negative 3, 0. So here's negative 3, 0. Knowing that my focus has to be inside the parabola allows me to make the conjecture that this is going to be some sort of sideways horizontal parabola. All right. Now, I don't know how wide it's going to be yet, but this is kind of my focus, which means the directrix needs to be on this side. And my directrix, since, I'm sorry, I messed up over here. Since the focus is negative 3, the directrix is the opposite, so that's a positive 3. Make sure that you make note of that. Mr. Sally messed up over here, so your directrix is a positive 3. So x equals positive 3 is the line. Whoops. Let's redraw this thing, make sure that we have a straight line going. And I don't know why I'm making it harder on myself. Here is my directrix. All right, now again, we already talked about which way the parabola is going to open, so we just have to make sure that we do it correctly. How wide the parabola is going to go is what your focal width is going to determine. Now, focal width, focus. This tells you the width from the focus point. Well, if the width total is 12, it means that from this focus point, I need to go up 6, and I need to go down 6. I'm having some issues today. Your parabola is going to hit the... Wow. There you go. Now, yours is going to look a little better because you have more control over it. but you get the gist. So that's how you graph a parabola. Anytime you're asked to find the focus or directrix, you have to put it in this form where the 4 shows up. Now, the problem came up earlier that we dealt with is when they say write the equation, so when they say write the standard form, remember in the standard form it's y squared equals 4px or x squared equals 4py. Regardless of what it is, I'm just going to do this as an example. This P represents your focus. So if this is what you're given and they say, oh, by the way, the focus is 3, 0. Well, I noticed that the 3 is the x value, which means that it has to be the one that has the x next to it. So y squared equals 4 times my focus, x. Notice how I didn't intentionally multiply a 4 by it. All I did is I plugged it into standard form, and standard form says the 4 is going to end up getting multiplied by it. This is when you have to write the equation. When the equation was given to you, that's when you had to take out that 4, so you're able to see what the focus actually is. All right, so that's parabolas in a nutshell. Now, when we talk about circles, circles are a little different. So let's kind of go to a different page here. Let's talk about circles. The equation for circles is x squared plus y squared equals r squared. So if I say something like x squared plus y squared equals 16, your radius is not 16. These correspond with each other. So r squared is 16, meaning what you have to do is take the square root, and you get your radius is equal to 4. All right? Now, the flip side of that is, let's say that I told you to write the equation. So I'm going to say write the equation of a circle with a radius of let's think here. 3. So if the radius is 3, well, I know that it's x squared plus y squared equals r squared. So x squared plus y squared equals r squared. So your final answer will look something like this. All right. What you have to make sure you take note on a circle is that the x squared is by itself and the coefficient is 1. The y squared is completely by itself and the coefficient is 1. If it's not 1, then you have to change it to that. So if they said something like 3x squared plus 3y squared equals 27. These coefficients are 3, so what you have to do is you first have to divide everything by 3, and you get x squared plus y squared equals 9. Think about what this means. It doesn't mean that your radius is 9. It means that r squared is 9. So when you take the square root of that, the radius is 3. So if we were graphing something like this, let me pull another graph up here. So if something like this was actually being graphed, your center is 0, 0. You're going to go up 3, to the right 3, down 3, and to the left 3. And the easiest way to do this is, that's one too many. Easiest way to do this is from point to point, you're just going to arc, 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 and arc again. And that will give you something pretty accurate to what the circle looks like. Let me see what else you have to look at with circles. The one other thing that comes up with circles that could be pretty challenging is when you have to write the standard form. So when the directions say write the standard form. Pay attention to this because this is something that I said we're going to work on in class. Remember, x squared plus y squared equals r squared is the standard form. So our goal is always we need to know what r is. But what if they say write the standard form given, instead of r, a point? So let's say they said, for this example, let's say they said write the standard form given this point. Well, what does this point even represent? This point represents an x and a y. So I'm going to plug them in. And remember, our goal again every time is we need to know what r is. So x squared plus y squared equals r squared. So I have 16 plus 36 equals r squared. This is 52 equals r squared. When I square root both sides, I do this to get r. Now, do I want to square root both sides? No, but I was trying to show you this because people get in the habit of kind of working too much. Remember, it's x squared plus y squared equals r squared. So all I really care about is making sure that I know what r squared is, which I do, and it is 52. So this is x squared plus y squared equals 52. So I guess to write the standard form, we really need to know what r squared is, because that'll end up giving us all the info we need. Let's do another one. Let's say that I gave you the point 5, negative 2. So x squared plus y squared. Notice how I'm putting the negative in parentheses, equals r squared. So we have 25 plus 4 equals r squared, and r squared equals 29. So my final answer is x squared plus y squared equals r squared, which is 29. And this is the final answer with the equation written in there. How are we doing on this? Okay, well, let's move on to the last shape. Oh, excuse me. To the last shape that we talked about through the video, so not even together, is this whole idea of an ellipse. All right. Now, what's unique about an ellipse is kind of like a circle, except for a few things. First of all, your answer will always equal 1. That is the standard form. Which means that if this number is something different, you need to divide by whatever it is to get it to equal 1. Also, an ellipse all deals with fractions. So it'll be x squared over some number plus b squared. An ellipse is basically a parabola and another parabola. They're always pointing towards each other. They like each other, so they have a positive relationship. Try to connect this positive relationship because they're looking at each other. Okay, this one wants to be a little difficult, very difficult. So they have a positive relationship right here. Keep that in mind as you're going through this to help you remember, because hyperbolas are going to be flipped around. They have a vertex, just like parabolas do. They have a focus, just like parabolas do. And just like all parabolas, their focus is on the inside. Now, there's also these 2 points right here, and these 2 points are called covertices. So just like they have a vertex, the main one, they also have kind of like a minor vertex, if you want to think about it that way. How you know when the vertices are or the main vertices is it all depends on the equation. So let's look at some sort of example. Let's look at something like x squared over 36 plus y squared over 9, and all of that equals 1. So the first thing that you do to figure this out or to even graph it is you're going to look at the denominators, and you want to see which number is bigger. Well, 36 is bigger, which corresponds with your x's. They're in the same fraction. So that means that your vertices are going to have some sort of x value right here, and the y value is 0. To figure out that x value, it's going to be the square root of the denominator. So the square root of 36 is positive 6 and a negative 6. So I'm going to go ahead, and before I do that, I'm going to now find the covertices. The covertices is whatever's left here. Now, if you notice, this 9 corresponds to the y values, which means that I'm going to get a y value here. So 0 is going to go where the x's are. And what's the square root of 9? 3. So let's take a look at what this graph might look like. So the graph itself is easy. The hard part is the foci, or the focuses. So we have 6, 0. So here's 6, 0. 2, 4, 6. 2, 4. So here is 6, 0. And my covertices are 0, 3. And 0, oh, I forgot the negative here. 0, negative 3. And then you're going to draw the smooth shape of an ellipse. There we go. Now, to figure out my foci, which is plural for focus, yeah. You are going to connect this with your vertices, right? Because it's only the vertices that have an actual focus. So you're going to have two of them because you have two vertices. Notice how the x values are what's accounted for here. So I'm going to figure out what the x value is. Your focus is always c squared equals a squared minus b squared. What does that even mean? Well, your a squared is the denominator, and b squared is the other denominator. You're essentially, the easiest way to think about it is you're always taking the big number minus a small number. Now, do I need to square 36? No, because 36 is actually a squared minus b squared, which is 9, and that gives me c squared. So as I work through this, c squared equals, what do we get, 27, square root of 27, and c equals plus and minus 3 radical 3. So remember, they're going to be somewhere around here. So it'll be 3 radical 3, 0, and negative 3 radical 3, 0. So what's 3 radical 3? We are talking about 4 and some change. So 1, 2, 3, 4 and some change. And 1, 2, 3, 4 and some change right there. So here is how you graph an ellipse. Now, one thing I do want to point out with ellipses is sometimes you're going to get things like this, where does not equal 1. So what you have to do is you have to divide them by 144. And then simplify. So when I simplify this, I get x squared over 16 plus y squared over 9 equals 1. So now it's in standard form. So to figure out the focus, or the foci, I take, remember, the foci, which is c squared, is a squared plus b squared. Or I'm sorry, minus b squared. And we just said a squared is a bigger number, so 16 minus 9. So c squared equals 7, square root. So your foci here, is plus and minus 7. So c equals plus and minus 7. Now remember, foci are points, so I need to first see which way this thing opens up. So to figure out which way it stretches more, we look at the denominators again. Which one's bigger? 16. And since the x values are what correspond with 16, this thing stretches on the x-axis. So it'll be, this was square root, making all sorts of mistakes here. So this will be positive 7, 0, and negative radical 7, 0. So that is your foci. To figure out the vertices, I'm going to take the square root of the bigger number, which is 4. So my vertices are 4, 0, and negative 4, 0. We'll get into this a little bit more. Oh, let's get rid of this. We'll get into this a little bit more later, but this is just kind of an overview of what is to come. Later on, we're going to write equations of vertices, and then we will end up going from there. So thank you for your time, and I hope that this was a little helpful. Please make sure that you review these things if you need help. These problems are all from your pink extra practice packet, so figure out which problems they are and start lining them up. Hope this helped. Thanks.